Hello students and welcome back to my channel. Today we are going to see miscellaneous exercise of matrices from question number 1 to 8. Okay, so let's begin. Now in the very first question, we have been given one matrix. Let A is equal to this 2 by 2 matrix. You want to show that AI plus BA raised to n is equal to A raised to n into I plus n into A raised to n minus 1 into B into A, where small a and small b are constant terms and n belongs to any natural numbers and I is an identity matrix of the order 2 by 2. Okay, तो एक इक्वेशन जैसा हमको प्रूव करना है. So students will be proving this with the help of principle of mathematical induction which you have studied in your 11th standard. Okay, तो उसमें याद है you have to start the sum like this. Let Pn is the given relation. ये जो पूरा relation उसको हम लोग डिनोट करेंगे P of n से. Okay, now it's a 3-step procedure. In the step number 1 you have to prove that P of 1 is true. In the step number 2 you assume that P of k is true. And in the step number 3 we have to prove that P of k plus 1 is true. So let's come to the step number 1. To prove that P of 1 is true. तो यहाँ पे जो आपने P of n डिनोट किया हुआ है उसमें LHS और RHS दोनों ही सेटिस्फाई करना है for n taking the value 1. Okay, so if we solve the LHS in your P of n, I am putting the value of n as what? 1. इसको कंपेयर करो, n का वैल्यू हम लोग क्या पुट कर रहे हैं 1. So LHS में n का वैल्यू 1 पुट करेंगे. So wherever you see n in the LHS, we are going to put the value 1. So you get a into I plus BA the whole raised to 1, which remains AI plus BA. So this is your LHS for P of 1. Coming to the RHS, जहाँ पे भी आपको n दिख रहा है वहाँ पे आपको क्या पुट करना है 1. Okay, so I am going to get your a raised to 1 into I plus ये n के बदले 1 पुट करो a raised to 1 minus 1 into b into a. Now what is a raised to 1 into I? It is ai and anything raised to 0 is 1. So 1 into you are going to get your 1 plus into b into a. So we get ai plus ba which is same as your LHS. So this relation P of n is true for n taking the value 1. तो ये फर्स्ट स्टेप हो गया. ओके, स्टेप नंबर 2 में हम लोग क्या अज्यूम करते हैं कि P of k is true. We are assuming that when n is equal to k, the given relation is true. तो जहाँ पे भी आपको n दिख रहा है वहाँ पे आपको k पुट करना है. ओके, सो ai plus ba raised to n के बदले we are putting k is equal to a raised to k into I plus ये n के बदले k a raised to k minus 1 into b into a. So let that be equation number 1. Okay, you can't simplify further, so let that be equation number 1. Coming to the step number 3, we have to prove that P of k plus 1 is true. Means n takes the value k plus 1, you have to prove that this relation is true. So coming to the LHS, जहाँ पे भी आपको n दिख रहा है वहाँ पे आपको क्या पुट कर रहे हैं अभी k plus 1. So I am going to get ai plus ba raised to k plus 1. Okay, now according to law of indices you can split this in two bracket. The bracket raised to k plus bracket raised to 1. Okay, ये law of indices हमने यूज किया है. कौन सा रिलेशन यूज किया है? x raised to m plus n is same as x raised to m into x raised to n. Okay, now this value you have in equation number 1. देखो equation 1 में हमको ये bracket का value मिला हुआ है. So instead of this bracket I am going to put this value now. So I get a raised to k into I plus k into a raised to k minus 1 plus into ba, bracket closed, and this bracket raised to 1 which remains as it is. Now we open the bracket, students. Okay, so when they multiply you get a raised to k into a is going to become a raised to k plus 1 and I into I becomes I square. Then this term multiplies here, you are going to get a raised to k into b into I into a. तो पहले जो कांस्टेंट टर्म्स है ना उसको हम लोग लिख रहे हैं. a raised to k is constant, b is constant, and then the identity matrix and then the a matrix. Then we take this term with the second bracket, so you get k is a constant term, फिर a raised to k minus 1 into a, it is going to become a raised to k minus 1 plus 1, the powers will get added, and b into a into I. Now this term multiplies here, so we get k a raised to k minus 1, b into b becomes b square and a into a becomes a square. Okay, so we have got this relation. Now what is the value of I square? I into I is always I. Identity matrix into any matrix is the same matrix, therefore I into a we get a. Okay, and in this term k minus 1 plus 1, so you are left with a raised to k. So you get k a raised to k be a and then this term as it is. Now students, ये सारे टर्म में और फर्दर सिंप्लीफिकेशन पॉसिबल नहीं है, बट ये टर्म में सिंप्लीफिकेशन इज पॉसिबल बिकॉज यू हैव ए स्क्वायर. सो व्हाट वी आर गोइंग टू डू इज वी आर गोइंग टू फाइंड ए स्क्वायर फर्स्ट. तो ए स्क्वायर मीन्स ए इंटू ए. मैट्रिक्स मल्टीप्लीकेशन कर लो, तुमको जीरो मैट्रिक्स आएगा. ओके, सो we got the value of a square as 0. So if you put here, so this full term becomes 0. So your LHS now reduces to this term as it is, this term as it is, this term as it is, and this term has now become 0. So LHS is your these three terms. Okay, coming to the RHS, उसमें अभी जहाँ पे भी आपको n दिख रहा है वहाँ पे आपको क्या पुट करना है, k+1. तो देखो we are going to get here a raised to k+1 into I plus instead of n I am going to write here k+1 a raised to k+1 minus 1 into b into a. Now this term remains as it is. Here I am going to open the bracket. So k multiplies with this term, so you get k, यहाँ पे क्या हो जाएगा, a raised to k into b into a plus 1 multiplies with this term, so you get the same term. Okay, so now if you compare LHS and the RHS, they both are same. So what we have completed? We have completed 3 steps of principal mathematical induction: step 1, step 2 and step 3. Okay, so if you write a conclusion from steps 1, 2 and 3, and by principle of mathematical induction, P of n is true for all n belongs to n. Simple. Okay, let's move to the second question. Again, one matrix A is given to us. You want to prove that a raised to n is equal to this matrix is true for all n belongs to n. So again students will be taking the help of principle of mathematical induction. आगे जो हमने 3 स्टेप किया वही स्टेप यहाँ पे आपको रिपीट करना है. Okay, so how do we start? Let P of n is equal to this relation. Let P of n denote this relation. Now 3-step procedure begins. Step number 1, you want to prove that P of 1 is true. Okay, so ये आपका LHS है, ये आपका RHS है. तो LHS में n के बदले भी क्या पुट करेंगे, 1. So I am going to get a raised to 1 is a and your matrix A is this value. So I am going to put here. Okay, RHS में जिधर भी आपको n दिख रहा है उधर क्या पुट करेंगे, 1. So you are going to get 3 raised to 1 minus 1 everywhere. You know, 3 raised to 0. So all the values become 1. So LHS and RHS both are same. So therefore P of 1 is true. In step number 2, what do we do is assume that P of k is true. तो जहाँ पे भी आपको n दिख रहा है वहाँ पे क्या पुट कर देंगे, k. तो you get a raised to k is equal to 3 raised to k minus 1 in all the 9 terms. That is your equation number 1. Coming to the step number 3, you have to prove that P of k plus 1 is true. So in your LHS, instead of n I am going to put k plus 1. So I get a raised to k into a. A raised to k का वैल्यू यहाँ पे है हमारे पास. You put this matrix over here and matrix A is this one. So now we do matrix multiplication. The order of this matrix is 3 by 3. इसका भी order 3 by 3 है. Matrix multiplication is possible. Net order 3 by 3. So if you remember, 3 by 3 has 9 elements. Okay. So A11 कैसे मिलेगा हमको? First row, first column. So 3 raised to k minus 1 into 1 plus 3 raised to k minus 1 into 1 plus 3 raised to k minus 1. Now students, एक चीज़ ऑब्जर्व करो, हर एक टर्म हमको सेम मिलने वाला है क्योंकि इधर मैट्रिक्स A is what 1 1 1 1 1 1. Okay, so that is why all the terms are similar. Now ये तीनों ऐड होके हमको क्या मिलेंगे, 3 times 3 raised to k minus 1. Again everywhere we get 3 times 3 raised to k minus 1. Okay, so according to law of indices, you are going to get 3 raised to 1 plus k minus 1 everywhere. So let's see now. So ये देखो ऐसे मिलेगा हमको, 1 and 1 gets cancelled everywhere. So you get 3 raised to k, 3 raised to k, 3 raised to k in the full matrix which is your RHS. देखो ना RHS में अगर हमने n का वैल्यू k plus 1 पुट किया तो क्या मिलेगा, 3 raised to k plus 1 minus 1. So 1 and 1 would get cancelled and you get everywhere in the RHS 3 raised to k. Okay, so we can say this is your RHS matrix, and then we write a concluding statement from steps 1, 2 and 3, and by principle of mathematical induction, P of n is true for all n belongs to n. Okay, third sum is also the same. Matrix A is given to us. You want to prove that this relation a raised to n is true for all n belongs to n. Positive integer means natural numbers. Okay, तो वही 3 step procedure हमको करना है. How to start? Let P of n denote this relation. Then step number 1 में क्या प्रूव करते हैं? To prove that P of 1 is true. So LHS में n के बदले क्या पुट किया, 1. तो a raised to 1 is equal to a. So you get this given matrix. RHS पे आ जाओ, जिधर भी आपको n दिख रहा है उधर 1 पुट करेंगे. So you get this matrix which is same as LHS. Therefore LHS equal to RHS. Therefore P of 1 is true. Step number 2, assume that P of k is true. Means जहाँ पे भी आपको n दिख रहा है उधर क्या पुट करना है, k. So you get a raised to k is equal to 1 plus 2k minus 4k k 1 minus 2k. This is your equation number 1. Step number 3 में to prove that p of k plus 1 is true, coming to the left hand side. तो इसमें n के बदले what we are going to put k plus 1. So you get a raised to k plus 1. According to law of indices you get a raised to k into a. a raised to k का वैल्यू यहाँ से उठाओ, a का वैल्यू यहाँ से उठाओ. Okay, this is 2 by 2 matrix, 2 by 2 matrix, multiplication possible, net order 2 by 2, so that is simple. So this is your LHS matrix. Coming to the RHS, जहाँ पे भी आपको n दिख रहे हैं वहाँ पे क्या पुट करना है, k plus 1. So I get 1 plus 2 times k plus 1 minus 4 times k plus 1, k plus 1, 1 minus 2 times k plus 1. इसको simplify किया तो you get LHS equal to RHS. Okay, so all the 3 steps done. So we can say LHS equal to RHS, P of k plus 1 is true. So from steps 1, 2 and 3 and by PMI, given P of n is true for all n belongs to n. Clear? Simple question. Okay, so coming to the question number 4. What is given? If A and B are symmetric matrices, you have to prove that AB minus BA is a skew symmetric matrix. Okay, so let's start. Since A and B are symmetric matrices, therefore you can say that A dash is equal to A and B dash is equal to B. This is the definition for symmetric matrices. Okay, now what do we do is consider AB minus BA the whole dash. इसके ट्रांसपोज से सम चालू करो. Okay, so now what is the formula for A minus B the whole dash? It is A dash minus B dash, है ना. तो ये देखो ये A जैसा है, this is like B. तो A minus B the whole dash. This transpose will split with both the terms. So you get AB the whole dash, which is similar like A dash minus BA the whole dash. Okay. Now you know that PQ the whole dash is same as Q dash into P dash. तो it is like PQ. तो यहाँ पे इसका आंसर क्या मिलने वाला है? It is B dash into A dash minus इसका आंसर क्या मिलेगा? A dash into B dash. And in the starting we have seen that A dash is equal to A and B dash is equal to B. तो B dash को B से replace करो, A dash को A से. This is A and this is B. Now what if I take minus sign common from these two terms? So I am going to get AB minus BA the whole dash is minus of AB minus BA. So ये ऐसे नहीं फॉर्म में है, P dash is equal to minus P. So which is the definition of a skew symmetric matrix. So if a matrix का transpose is negative of the matrix, then you can say that this is a skew symmetric matrix. Okay, let's move to the fifth question. Show that the matrix B dash AB is symmetric or skew symmetric according as A is symmetric or skew symmetric. मतलब इसमें दो पार्ट हमको प्रूव करना है. फर्स्ट पार्ट में क्या प्रूव करेंगे कि B dash AB जो मैट्रिक्स है that is symmetric if A is symmetric and it is skew symmetric if A is skew symmetric. तो दो पार्ट है प्रूफ में. Okay, so let's start with the first part. We are assuming that A is symmetric. तो A symmetric है तो क्या बोलेंगे? A dash का वैल्यू क्या होता है? A. Now again we consider the transpose of this full thing. Okay, so इसको अभी थोड़ा सा सिंप्लीफाई कर देते हैं. B dash को एक टर्म रखो और AB को एक टर्म रखो and then put bracket and then it's like A into B the whole dash. तो ये एक टर्म है, ये दो टर्म है. Okay, so what is PQ the whole dash? It is Q dash into P dash. So according to this property, what we are going to get here? AB the whole dash into B dash the whole dash. Okay, so what is B dash the whole dash? ये हमने आगे देखा था. It is going to be B and AB the whole dash, it is what? B dash into A dash. Clear? But we have seen that A dash is what? A. तो A dash को A से replace करो. So did we get इसका transpose is the same matrix? Okay, so what we conclude that it is of the form A dash is equal to A, therefore B dash AB is a symmetric matrix. Okay students, moving to the second part of the proof. Let A is skew symmetric, therefore you can say that A dash is equal to minus A. This is the definition of skew symmetric matrix. Okay, so again we start with the transpose of the full matrix. तो इसको वापस rearrange करो. Consider this as one term, this is the second term and then the whole dash. तो PQ the whole dash is same as Q dash into P dash. तो इधर क्या मिलेगा? AB the whole dash into B dash the whole dash. लेकिन B dash the whole dash becomes B and A dash what we have seen it is minus A. तो इसको मैं minus A से replace करूँगा. Since minus is a scalar term, we can take ahead. So you get minus of B dash AB. So what did we get? B dash AB the whole dash is minus of B dash AB, which is of the form P dash is equal to minus P. तो एक मैट्रिक्स का ट्रांसपोज is equal to negative of the matrix मिलता है. तो you can say that this is a skew symmetric matrix. Clear? Okay, so let's move to the sixth question. You want to find the values of x, y, z if the matrix A is given to us and it satisfies the relation A dash into A is I. So we start with the relation A dash into A is I. A dash means the transpose. तो इसका ट्रांसपोज क्या होगा स्टूडेंट्स? फर्स्ट रो becomes the first column, second row becomes the second column, third row becomes the third column into the matrix A as it is, and I means we are going to choose identity matrix of the order 3 by 3 क्योंकि A का ऑर्डर 3 by 3 है यहाँ पे. ओके, सो नाउ इसका ऑर्डर देखते हो यहाँ पे मल्टीप्लिकेशन इज पॉसिबल. नेट ऑर्डर यू गेट इज 3 by 3. ओके, सो 3 by 3 में 9 एलिमेंट्स होते हैं. हाउ टू ऑब्टेन A11? फर्स्ट रो फर्स्ट कॉलम, तो देखो क्या आएगा यहाँ पे 0 प्लस एक्स स्क्वायर प्लस एक्स स्क्वायर, दैट्स योर A11. A12 कैसे मिलेगा? फर्स्ट रो सेकेंड कॉलम, सो यू गेट 0 प्लस एक्स वाई माइनस एक्स वाई. A12 फर्स्ट रो थर्ड कॉलम, 0 माइनस एक्स जेड प्लस एक्स जेड. A21 second row first column, so you get 0 plus xy minus xy. A22 second row second column, so you get 4y square plus y square minus y square. A23 second row third column, you get 2yz minus yz minus yz. A31 third row first column, 0 minus xz plus xz. A32 third row second column, 2yz minus yz minus yz. And A33 third row third column, z square plus z square plus z square. Okay, so if you simplify this you get your 2x square, ये cancel हो जाएगा 0, ये cancel हो जाएगा 0, cancel 0, you get your 6y square. ये सारे टर्म्स आपस में cancel हो जाएंगे, you get 0, this becomes 0, ये 0 हो जाएगा, यहाँ पे मिलेगा 3z square. Now by equality of matrices you can equate the corresponding element. So 2x square is 1, then 6y square is 1 and 3z square is 1. So if you simplify you get x square is half, so x is plus minus 1 by root 2, y is plus minus 1 by root 6 and z is plus minus 1 by root 3. Okay, moving to the seventh question. For what values of x is this relation satisfied? Okay, so let's start. This is the given relation. Okay, let's start the solution. यहाँ पे पहले इन दोनों को मल्टीप्लाई कर देते हैं, या पहले इन दोनों को भी मल्टीप्लाई कर सकते हो, फिर उसके रिजल्टेंट को इसके साथ मल्टीप्लाई कर सकते हो. यू कैन फॉलो एनी वे. सो लेट्स स्टार्ट. दिस इज 3 by 3, दिस इज 3 by 1. नेट ऑर्डर इज गोइंग टू बी 3 by 1. तो 3 by 1 में 3 rows and 1 column. ओके, सो यू कैन इजीली इमेजिन द एलिमेंट्स कौन से होंगे. A11, A21 एंड A31. ओके, तो A11 कैसे मिलेगा? फर्स्ट रो फर्स्ट कॉलम, तो यू गेट 0 प्लस 4 प्लस 0. ओके, A21 कैसे मिलेगा? सेकेंड रो फर्स्ट कॉलम, तो यू गेट 0 प्लस 0 प्लस x. A31 थर्ड रो फर्स्ट कॉलम, तो 0 प्लस 0 प्लस 2x. ओके, सो वी गॉट अ मैट्रिक्स ऑफ द ऑर्डर 3 by 1. इसका ऑर्डर है 1 by 3. नेट ऑर्डर में हमको मिलेगा वापस 1 by 1. सो फर्स्ट रो फर्स्ट कॉलम, तो यू गेट 4 प्लस 2x प्लस 2x. तो इसका ऑर्डर क्या है? 1 by 1. ओके, तो वी हैव 0 ऑन द राइट हैंड साइड. स्टूडेंट, दिस 0 इज एक्चुअली अ 0 मैट्रिक्स. तो LHS पे जो आपका मैट्रिक्स है वही आप 0 मैट्रिक्स का ऑर्डर ले सकते हो. सो आई एम टेकिंग अ 0 मैट्रिक्स ऑफ द ऑर्डर 1 by 1 सो दैट वी कैन से बाय इक्वालिटी ऑफ मैट्रिसेस 4x plus 4 is equal to 0. तो x का वैल्यू आ जाएगा -1. ओके, मूविंग टू द लास्ट क्वेश्चन ऑफ दिस लेक्चर. क्वेश्चन नंबर 8. मैट्रिक्स A is given to us. You want to show that a square minus 5a plus 7 is equal to 0. तो स्टूडेंट ये आपको तो बहुत सिंपल लगता होगा अभी. ओके, let's start with the LHS. a square minus 5a plus 7a. a square means what? a into a minus 5 into a plus 7 into I. a square मल्टीप्लाई कर लो तो यू गेट अ मैट्रिक्स ऑफ द ऑर्डर 2 by 2. 5 को अंदर स्केलर मल्टीप्लिकेशन कर दो, 7 को अंदर मल्टीप्लाई कर दो. ओके, सो नाउ इफ यू सिंप्लीफाई यू आर गोइंग टू गेट 8 minus 15 plus 7, 5 minus 5 plus 0, minus 5 plus 5 plus 0 and 3 minus 10 plus 7. So it comes out to be a 0 matrix. समझ में है स्टूडेंट्स? Okay, so in the next lecture we continue from the question 9 onwards. Till then, take care and goodbye.